On January 13, 2025, at 9:09 p.m. local time, a massive 6.9 magnitude earthquake rocked the Hugin Sea off Japan's southwestern coast, shaking the Miyazaki prefecture. While Japan frequently experiences seismic activity due to its position along the Pacific Ring of Fire, this particular earthquake may have set off alarm bells thousands of miles away beneath Yellowstone National Park in the United States. Yellowstone, home to one of the most formidable supervolcanoes on the planet, harbors a colossal magma chamber capable of reshaping the planet if disturbed. Could this distant quake, more than 5,000 miles away, send shockwaves through the Earth's crust and subtly destabilize Yellowstone's precarious balance? The Earth is more interconnected than we often realize. Japan's seismic upheaval serves as a stark reminder that even far-flung tectonic forces can ripple across continents. Beneath Yellowstone's iconic geysers and lush forests lies a massive magma chamber stretching 60 kilometers long and 40 kilometers wide. Buried beneath layers of solid rock, this volatile reservoir contains molten rock, crystallized minerals, and pressurized gases. Yellowstone has erupted with catastrophic force 3 times in the past 2.1 million years, with the most recent eruption 631,000 years ago, altering ecosystems and blanketing much of North America in volcanic ash. While the supervolcano has been relatively quiet since then, it remains far from dormant. Its magma chamber is continuously fed by a deep mantle plume, a column of molten rock rising from the Earth's depths, steadily building pressure over millennia. When a powerful earthquake strikes, it releases seismic waves that travel vast distances through the Earth. These waves are categorized into primary P waves and secondary S waves, which interact differently with the Earth's interior. P waves are fast-moving compression waves capable of traveling through solids, liquids, and gases. They penetrate deep into the Earth's core, compressing and relaxing rock layers as they pass. S waves are slower and move in a side-to-side motion, traveling only through solid material and creating shear forces that can exacerbate fractures in the crust. Japan's earthquake, with its immense seismic energy, sent these waves racing across the globe. While the direct risk of this event triggering an eruption at Yellowstone is low, the possibility that these waves could subtly jostle the delicate system cannot be dismissed. The Earth operates as a vast, interconnected system where energy released in one region can have far-reaching effects elsewhere. Seismic waves from Japan's quake may slightly redistribute pressure within Yellowstone's magma chamber, disturb its hydrothermal system, or even create micro-cracks in the surrounding rock. These disruptions, though typically minor, can act as a reminder of how fragile such a volatile system truly is. Yellowstone's extensive network of faults and fractures makes it particularly sensitive to external forces. Even if these seismic disturbances are unlikely to trigger a volcanic eruption, they may gradually destabilize the system over time. Fortunately, Yellowstone is one of the most closely monitored geological systems in the world. The Yellowstone Volcano Observatory, YVO, employs seismographs, GPS sensors, and gas detectors to track changes in ground deformation, seismic activity, and gas emissions. As of now, the YVO reports no signs of imminent danger. The ground remains stable, and the system appears to be holding steady. Japan's earthquake is a reminder of Earth's dynamic and interconnected nature. Yellowstone, though seemingly isolated, is part of a planet-wide system where energy travels seamlessly across vast distances. The idea that a quake on the other side of the world could stir a sleeping giant is both scientifically fascinating and deeply unsettling. While Yellowstone continues its slumber, the distant earthquake serves as a powerful illustration of the Earth's constant motion and the latent potential for the unexpected. You may have heard that Yellowstone National Park is located on top of a big supervolcano. In 2015, researchers from the University of Utah discovered a massive magma chamber beneath Yellowstone, which is responsible for the area's powerful geysers and hot springs. They also observed another reservoir with magma beneath the top, indicating that larger chambers contain more magma. Together, the two reservoirs store a glob of magma. The magma chambers have the potential to fill the canyon's capacity 11 times. However, they often press against the ground above them, which is concerning. The landing Yellowstone is an active volcano with a seismic explosivity index of 8 out of 8, indicating a potentially catastrophic eruption. The 1991 Pinatubo eruption in the Philippines, considered the most intense in living memory, received an air rating of 6 on the Volcanic Explosiveness Index. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in Yellowstone National Park. The most significant included a magnitude 3.7 mini-earthquake that occurred as part of a swarm of 106 earthquakes that began on March 29th and lasted until the end of the month. Experts warn that earthquakes can occur in swarms, particularly in Yellowstone. Although more active than normal, the situation is not critical. According to geophysicist Michael Pollan at the Yellowstone Volcano Observatory, the volcano will not erupt anytime soon due to the lack of sufficient magma and pressure to cause magma to rise. The volcano is currently stable, and Pollan and his team are monitoring underground activity for potential eruptions. Frequent earthquakes and ground deformation can cause significant changes on the ground surface. The earth in that area can be frightening, so the team monitors it. Temperature of the park's thermal features. This is another warning sign of a potential calamity. Yellowstone's geyser activity, gas and thermal emissions, and park-wide changes do not indicate a looming eruption due to a 70,000-year-old eruption. This is a common misunderstanding about volcanoes, which do not follow timelines. If a supereruption occurs, the main concern would be earthquakes rather than lava flows. The Yellowstone volcano has had 3 mega eruptions, the most violent of which was 2,500 times more deadly than the 1980 explosion of Mount St. Helens in Washington state. The most recent supereruption, known as the Lava Creek eruption, formed Yellowstone. Calora scientists have discovered 2 previously unknown supereruptions that occurred around 9 and 8.7 million years ago. The younger of the 2 is now considered the largest recorded event in the Snake River Yellowstone Volcanic Province. The younger of the 2 events is now considered the largest recorded event in the Snake River Yellowstone Volcanic Province. We can speculate on what happened millions of years ago based on evidence. The first signs of the disaster appeared thousands of years before the catastrophe. It has been melting rock beneath the planet's crust, creating massive chambers. The volcanic system was filled with a pressured mixture of semi-solid rock magma, water, vapor, and gases, such as carbon dioxide. As more magma arrived, the underground soup grew. The area surrounding the volcanic system was also impacted. A year before the super eruption, Yellowstone gave a warning signal, but no one could interpret it. Alarming processes were taking place underground, such as decompression, which can cause gas bubbles to burst and cause specific types of eruptions. Small-scale earthquakes became more frequent and intense in the months leading up to the eruption. As the supervolcano erupted, the ground grew increasingly active and intense in several locations. During the eruption, the surface and groundwater became warmer, and there was peculiar vapor fogging in the area. As pressure increased, the ground over the magma chamber pushed up, creating a dome-shaped uplift with narrow cracks along the edges. This was similar to opening a bottle of soda after shaking it. Cracks began to open along the dome's edges, similar to opening a bottle of soda after shaking it. This occurred near the volcano, bringing to mind Mentos and Dio. The Yellowstone volcano's geothermal pools and geysers heated up to boiling temperatures and became more acidic, causing magma to rise to the surface. At one point, the rock roof of the magma chamber could no longer withstand the pressure, resulting in a small but continuous eruption. Ground tremors started days before the disaster, although significant shaking did not occur until several days later. Before the eruption, a massive column of lava and ash was hurled into the air, followed by a pyroclastic flow that rushed across the area at a hurricane speed. The flow was a liquid mixture of half-solid lava pieces, volcanic ash, and hot gases, resembling an extremely hot toxic snow avalanche with a temperature of around 1,300 degrees. The volcano continued to pump ash for days on end. The volcanic eruption's ash fallout posed a significant risk. Within seconds of inhaling ash, it transforms into glassy cement, killing most animals and causing trees to collapse. Within a few days, a thick layer of ash covered vast territories, causing temperatures to drop globally due to the eruption's rich sulfur content, which acts as a sun blocker. This natural calamity is known as the Gray's Landing mega-eruption. According to recent studies, the Gray's Landing super-eruption was a massive natural disaster that covered an area the size of New Jersey with scorching hot volcanic glass. This instantly sterilized the land surface, wiping out all plant life that had previously thrived. If a volcanic eruption were to occur today, it would cover Colorado, Utah, and Wyoming with toxic ash, causing widespread darkness and destruction of crops, pastures, power lines, and electrical transformers. It is fortunate that such a disaster is not expected. Gas emissions are within normal levels, and the subtle pulse of earthquakes beneath the park remains routine. But history teaches us that supervolcanoes awaken slowly and unpredictably. The 2025 Japan earthquake serves as a stark reminder of how fragile and interconnected our planet truly is. A violent shift beneath the Pacific can send silent ripples toward the heart of North America, stirring forces that have slept for thousands of years. Yellowstone may not be ready to erupt now, but every tremor, near or far, tells a story. A story of pressure building, ancient forces in motion, and a world where even distant events can awaken giants. Though it sleeps now, scientists have long studied the unimaginable consequences of what might happen if Yellowstone erupted today. This is not a question of mere curiosity. It is a journey into one of Earth's most extreme hypothetical scenarios where nature's raw power meets human vulnerability. Beneath the sprawling landscapes of Yellowstone lies a massive magma chamber stretching over 60 kilometers in length and 40 kilometers in width, filled with molten rock, pressurized gases, and volatile energy fed by a deep mantle plume rising from Earth's core. If it were to erupt again today, the consequences would be far beyond any disaster humanity has ever faced. The eruption could begin subtly. Perhaps an unusual series of earthquakes would rattle the park, signaling magma rising through fractures in the Earth's crust. Geysers might erupt with unprecedented force, steam vents could roar louder, and the ground might begin to swell as magma pushes upward. Then, without warning, a cataclysmic explosion could rip through the surface. Superheated ash, rock, and gas would blast skyward, piercing the stratosphere with unimaginable force. The eruption column could climb over 30 kilometers, nearly 20 miles high, dispersing volcanic ash across vast swaths of North America. Within hours, the immediate fallout would be devastating. Within a 100-mile radius, everything would be obliterated. Forests, rivers, and wildlife would be buried under feet of volcanic ash. Pyroclastic flows, searing clouds of molten rock and gas, would move faster than hurricanes and hotter than any wildfire. Entire communities in Wyoming, Montana, and Idaho would vanish in moments, leaving behind a wasteland of ash and rock. But the devastation wouldn't stop there. Ash particles carried by jet streams would spread across the United States and beyond. Major cities like Denver, Chicago, and even New York could find themselves under layers of ash, crippling transportation, collapsing power grids, and contaminating water supplies. The fine ash, sharp as glass, would clog engines, damage electronics, and make the air dangerous to breathe. Farming across the Midwest, the heart of America's food supply, would come to a halt as crops suffocated beneath the ash blanket. Globally, the situation would spiral into chaos. The eruption would inject vast quantities of sulfur dioxide and ash into the upper atmosphere, forming reflective sulfate aerosols. These aerosols would block sunlight, causing temperatures worldwide to plummet. This phenomenon, known as a volcanic winter, could lower global temperatures by several degrees Celsius, disrupting weather patterns, shortening growing seasons, and triggering widespread crop failures. Famine could grip vulnerable regions, and even wealthier nations would scramble to secure food and resources. Rainfall patterns would shift unpredictably. Some areas would face devastating droughts, while others would be submerged by relentless floods. Monsoon cycles in Asia could collapse, crippling rice production and threatening the food security of billions. The oceans, too, would suffer as cooler temperatures disrupt currents and marine ecosystems, leading to massive die-offs in fisheries. Economically, the world would stagger under the weight of this disaster. Global markets would crash as supply chains crumble. Trade routes would be disrupted by ash, grounding airplanes and choking transport infrastructure. Countries would enter economic freefall, with industries dependent on agriculture, energy, and manufacturing taking devastating hits. Recovery could take decades. The human toll would be immeasurable. Millions could die from the immediate impacts of ash inhalation, infrastructure collapse, and food scarcity. Health systems, already strained by environmental disasters, would buckle under the pressure. Diseases could spread in crowded shelters where survivors seek refuge, and clean water would become as precious as gold. Social order might begin to fracture. Panic, scarcity, and survival instincts could ignite conflicts within and between nations. Mass migrations could overwhelm borders as people flee uninhabitable regions in search of safety. Governments would face impossible decisions: how to allocate dwindling resources, protect vulnerable populations, and maintain civil order in a world plunged into darkness. Yet, the full impact could unfold for years, even decades. Acid rain would poison rivers and lakes. Ecosystems would collapse under the dual pressure of climate change and environmental destruction. Species on the brink of extinction might disappear forever, and human societies would struggle to adapt to a new, harsher reality. How could this chain of destruction start? The mechanics are terrifyingly simple. Magma, rich in volatile gases, builds pressure beneath Yellowstone over thousands of years. This pressure accumulates slowly, fracturing the brittle crust above. If the rock weakens enough, magma could surge upward violently, releasing pent-up gases in an unstoppable explosion. Each step in this process, magma movement, gas buildup, rock fracturing, is monitored today. But even the most advanced science might only offer days or weeks of warning. And if the worst were to happen, we would be powerless to stop it. No technology exists to halt a supervolcano. Efforts to drill into the magma chamber or release pressure artificially remain theoretical and fraught with risks. Humanity could only watch as nature reclaims control. Yet, in this grim scenario, there is also a story of resilience. Science has given us tools to monitor, predict, and prepare. International cooperation could become our greatest strength, sharing resources, stabilizing economies, and supporting displaced populations. The human spirit, tested by adversity throughout history, might rise once again to rebuild. The Yellowstone supervolcano reminds us of Earth's immense power, a force far beyond our control. Its eruption, though unlikely in our lifetime, would be a defining moment in human history, a moment when our species would face the true scale of nature's fury and be forced to reckon with our place on this ever-changing planet. Yellowstone is underlain by two magma bodies. The shallower one is composed of rhyolite, a high silica rock type, and stretches from 5 kilometers to about 17 kilometers, 3 to 10 miles, beneath the surface, and is about 90 kilometers, 55 miles long, and about 40 kilometers, 25 miles wide. The chamber is mostly solid, with only about 5 to 15% melt. The deeper reservoir is composed of basalt, a low silica rock type, and extends from 20 to 50 kilometers, 12 to 30 miles, beneath the surface. Even though the deeper chamber is about 4.5 times larger than the shallow chamber, it contains only about 2% melt. The method that scientists use to discern this information is similar to medical CT scans that bounce X-rays through the human body to make three-dimensional pictures of internal tissue. In an analogous manner, a method called seismic tomography uses hundreds to thousands of earthquakes recorded by dozens of stations to measure the speed of seismic waves through the Earth, data that allow geophysicists to make three-dimensional pictures of structures beneath the surface. Scientists compare these seismic velocities and infer the composition by comparing them with average, thermally undisturbed values. Volcanoes that share common magma reservoirs can sometimes trigger unrest at each other. The 1912 eruption of Alaska's Novarupta volcano, the largest eruption of the 20th century, was fueled by magma that came from a magma reservoir beneath Mount Katmai, 10 kilometers, 6 miles away. Mount Katmai did not erupt, but after the eruption of Novarupta, Mount Katmai collapsed into the emptied magma chamber below it. Some individual volcanoes or vents are considered to be part of a larger volcano complex. In some such cases, one eruption doesn't really trigger a nearby vent to erupt, but moving magma finds its way to the surface at multiple sites. For example, Tavurvur and Vulcan cones are vents within Rabaul caldera in Papua New Guinea that erupted at nearly the same time in 1994. However, not all nearby volcanoes show this behavior. Hawaii's Kilauea volcano is located on the flank of Mauna Loa volcano, so the two are only 33 kilometers, 20 miles apart. Yet those two volcanoes have distinctly different magma reservoirs. Despite their proximity, an eruption at one does not appear to trigger an eruption at the other. However, the possibility of a catastrophic Yellowstone supervolcano eruption remains extraordinarily low in the foreseeable future. Geological records show that Yellowstone's last major eruption occurred approximately 640,000 years ago. Current assessments by the United States Geological Survey, USGS, estimate the annual likelihood of another massive eruption at a mere 0.14%, a statistical reassurance that such an event is unlikely to occur within many human lifetimes. Beneath the Yellowstone caldera, the vast magma chamber formed by past volcanic activity is closely monitored. Scientific studies reveal that this chamber is only 5 to 15% molten, with the remainder consisting of solidified rock. This limited amount of molten material suggests that the conditions necessary for a colossal explosive eruption are not currently present. While Yellowstone remains geologically active, with frequent small earthquakes and geothermal features like geysers and hot springs, these signs are typical of a dynamic volcanic system and not indicators of impending disaster. Ongoing monitoring by scientists worldwide ensures that any significant changes deep beneath the surface will be detected long before they pose a threat. If you found this video fascinating, don't forget to like, share, and subscribe for more deep dives into the world's most intriguing natural phenomena. Stay curious and stay informed. Until next time.